Computing the vibhaktis of the complex inflectional information. Next, a name entity recognizer is being inserted. Since this system was developed for tourism domain, where we get a lot of proper nouns. So to identify them and to disambiguate them, we need a name entity recognizer. Later, we identify the thematic roles, the relational information in the sentence with the help of simple parser, and a multi-word expression is also a multi-word expression module is also being inserted for identifying the complex compound nouns or compound verbs, compound words. The transfer grammar, where we transfer the structural information to the target side, from the source language structure to the target language structure. Once the structure is being transferred, we substitute the base forms using lexical substitution engine. Now it falls into the target language generation, where the agreement is being passed from the subject and predicate, and now the sentence is being ready to generate. We also have a vibhakti splitter, where the complex inflectional grammatical information is being splitted and rearranged in its order. Finally, we have a word generator, which generates the information using agreement as well as the morphological information, and tuning is being done to the target generated sentences with post-processing. This is a SSF format, where it is a columned format. We have 4 columns in this. First column always contains the address of the token or the word. The sentences are splitted into different tokens, and that token address is being saved in the first column, and the tokens fall into the second column. The POS category of that word and its chunk information is being stored in the third column. The morphological information and the relational information are stored in the fourth column. There are 2 kinds of analysis represented. One is constraint level analysis, and other is relational analysis. In the both ends, we use UTF-8 notation in the language script, but internally we work on WX notation. This is a dashboard that looks. The green button where press to run is shows. Click here to translate the sentences. In the left side, it is source language, and the right side, it is the generated target language. And these are the modules that have been integrated, and we call this as a pipeline. Since the architecture is a hierarchical one, we call this as a pipeline. So you can see the versions as well as the module name here. If you want to see the intermediate output of any module and correct it, you can correct here itself. So as I have said, we have a tokenizer which splits the words into, which splits the sentences into individual words, like the punctuation marks and the words. Morphological analyzer analyzes the word completely in isolation. This morphological analyzer works on word and paradigm method, which permits, which gives around 20 to 30 features of each single word. In this, since it is a consortium project, we have made some mandatory values. There are 8 in number, like root word, lexical category, gender, number, person, and etc. So these are the 9 lexical categories that are being used for that are used in morphological analyzer: noun, verb, adjective, pronoun, adverb, postposition, number, and NST, noun of space and time, and indeclinables. Next, it is POS tagger, which assigns the part of speech to the word in that context. It also helps in identifying the morphosyntactic function of the word in the sentence. We used 2 types of statistical engines, that is HMM as well as CRF. Since we find CRF was most accurate in identifying the POS categories, we are fixed with CRF right now. This CRF was trained with manually tagged data, which we call as gold standard text. Okay, around 20k, like 2 lakhs words have been tagged, and they have been trained to the CRF engine. So this tagging data was done using ILMT tag set, Indian Language Machine Translation tag set, that was decided by ILMT consortium. Next, chunking, the identification of non-recursive word groups is done in this chunker, and they involve noun phrase, verb phrase, adjective phrase, adverb phrase, etc. Okay. Identification of functional relevant information is also being done in this module, computational module. Since POS tagging is using the CRF engine, we also tried to implement this chunking with the same database. So that database is been manually tagged and trained to both CRF and HMM. Here also CRF has given a good result to us, so we fixed with CRF and we have integrated it. The same data is been tagged manually, and this follows ILMT tag set, chunking tag set. Next, name entity recognizer. Since we are dealing with tourism corpus, we expect a lot of proper nouns and place nouns to occur in the text. So it is very necessary to disambiguate them. Like when it is Jawaharlal Nehru, that Lal should not be substituted as red in Telugu. It should be Lal. So for that you have to tag that complete name as a proper noun. So we have introduced this module, which identifies the proper names, place names, organization names, etc. An amount of 20,000 nouns have been identified, collected, and with 1,000 sentences are tagged and trained against CRF. So next, the computational module is simple parser, where the sentence is being parsed and the basic relations are identified using Panni framework. It also involves the ontology to parse that sentence. The next module following this is multi-word expression, where we identify the multi-words, the compound words. It might be any like a noun or verb compounds. So here we capture the most frequent words like non-compositional phrases, reduplicatives, and we maintain a list and we substitute by seeing that list into the target language. Next, transfer grammar, where the structures have been identified. Here we mainly deal with the linguistic divergence. In spite of saying the structures, we deal with the linguistic divergence. It might be lexical divergence, it might be any other. We identify the structures and we transfer those structures into the target language structures. So the structures have been changed in this. So we have certain rules. Based on those rules, this module is been working. So it's a completely linguistic rules, not a statistical information is been given to this. A dictionary has been maintained to substitute those words, which we call as lexical transfer engine. This dictionary is of concept base, okay, where a lot of synonymous words are given to one concept, and using these concepts we substitute the words. These words are linked to one to one, one to many, and many to one. After substitution, we fall into the target language generation. The language has been analyzed, the information is been captured, and the words have been substituted. Now it's ready to generate. Before generation, we have to